Hi everyone, welcome back to Data Science in your Pocket. And today we are deep diving into an advanced topic around LLMs, that is fine tuning. And not just general fine tuning, we would be talking about a very important Python library, that is Unsloth. So I have been following their work for a very long time and I must say it's quite impressive. This is not a paid promotion, so don't be worried about it. I would be talking about how you can do fine tuning with Unsloth, why you should do fine tuning with Unsloth, and the best part is Unsloth reduces your GPU usage. Alongside, it makes the fine tuning two times faster, beat any LLM. So let's get started. Unsloth already provides codes also, so I'll be sharing that with you as well towards the later end. But first of all, let's understand some common pain points around fine tuning and how Unsloth is solving that. So, what is fine tuning? I think if folks might have heard of this term, but they might not understand the meaning. So, fine tuning is basically making an existing LLM adapt on your specific data set. Like, for example, you got a Llama 8B model, which is trained on all the generic data set available. So, Meta released it as a generic LLM. Now, you want it to be a superhero on finance data, for example. It should excel on any finance task. In that case, you need to fine tune. You need to improve the existing model to be an excel on your specific data set, that is called as fine tuning. Teaching a general model your unique task and tone transforms a general purpose model into a useful specialized tool, right? So this is what is fine tuning is. Now what are the pain points of traditional fine tuning, right? It is painfully slow. So basically most of the guys might be using Hugging Face Trainer for fine tuning the LLM. I'm jumping a little onto the codes now, and these are certain libraries, as you can see on my right, that you might be aware of: CUDA, PyTorch, Trainer, LoRa, Bits and Bytes, Accelerate, Deep Speed, etc. Now when you're using this with Hugging Face Trainer, excessive memory consumption is there. It is quite slow. Collapses with custom modification. Customization is very painful, that I have also tried out. And even huge GPU requirements are there for a 7 billion model. Now, how Unsloth is solving these things out? Unsloth is the actual solution. It is about 2 to 5 times faster depending upon the LLM you are fine tuning. It drastically reduces VRAM usage, that is the GPU. So now with less GPU also, you can train your LLM quite fast. You can train your LLM on Google Colab also. Yeah, compatible with existing tools and models like Bits and Bytes, Accelerate, etc. Quite simple code base that I have seen. I have used it for a quite couple of fine tuning tasks, and I must say they have done a great job. I'll be sharing you the codes also. Don't worry about it. So first of all, talking about the speed, as mentioned, the speed is quite great compared to standard fine tuning. How it is happening? It is using custom Triton based fused kernels. I'll be explaining you that. Don't worry about it. Kernels are specific programs written over GPU, right? Which replaces the slow PyTorch operation. So the default Hugging Face trainer uses some PyTorch operation that are quite slow, while Unsloth is using some other fused kernels. It also reduces certain Python overheads within the training loop. Hence, it is improving on the speed. And now, a 15-hour training job may just complete in 5 hours also. It is that fast. So, what is a Triton fused kernel? I will be just giving you a brief around how to understand it. Custom built shortcuts for GPU operations, right? So, you might be knowing what a kernel is in GPU. Kernels are specific programs you have written to perform certain operations. Triton fused kernels are shortcuts for GPU operations, combines multiple operations into one, hence less overhead and faster execution. It's like cooking in one pot versus multiple pans. So you are, for an example, if there is an operation A has to be performed, it would be done in 5 steps. Using Triton fused kernel, it would be done in just one step, all in one solution. I'm not jumping much into the technical details of it. I would be explaining it in a separate video or a blog. Lower VRAM usage by Unsloth is also one of its advantages. It is built for 4-bit quantized models, right? So most of the time, once you are quantizing the model already to 4-bit, you're already reducing your GPU utilization by a huge margin, I would say. And you can even fine tune 7 billion models on a single 24 GB GPU. Even 13 billion models are possible, not just 7 billion. Even fine tuning of 13 billion models is possible, which is great. And now using consumer grade GPUs, you can fine tune your LLMs. Compatible, I think it's the best part of Unsloth, that it is compatible with almost all the existing libraries that works with Hugging Face Trainer, beat flash attention, accelerate, bits and byte, etc., and algorithms like LoRa, QLoRa, flash attention. It supports all the models also, Mistral, Llama 5. Now they have introduced vision as well as audio models also. That's the best part. I would be covering a few of them in my upcoming videos, so don't worry about it. Talking about the technical deep dive, I think we have already talked about it. Triton fused operations for tighter GPU batching, efficient long sequence handling, and native 4-bit QLoRa integration. Optimized Python training loop. So there are three key features that you need to understand. One is the Triton fused kernels they are using. Second is the default 4-bit QLoRa integration, and third is removal of some Python code from the training loop, which is unnecessary. When to use Unsloth? That's an important question. Fine tuning models on consumer GPU, quick experimentation and iteration. Right? When not to use. It can't be used for pre training because it is not customized for that. Custom architectures or experimental setups, it might fail. So, why Unsloth? Because it's fast, it uses less GPU, and as you can see, as generative AI is progressing ahead, I think we need to tap onto the next step, that is not just inferring LLMs locally but also fine tuning them. And I think Unsloth is doing a great job on that end. No complex setup is required. I think they have given all the codes in quite some detail, so you just don't need to worry about anything. Faster iterations, better results. Now, before we end up this, how to use Unsloth, let me show you that too. So here you can see that we are at the official documentation of Unsloth. Easily fine tune and train LLMs, get faster with Unsloth. Now, if you click here, you will land on to Unsloth documentation, which is quite easy. They cover almost all the models, Qwen 3, Gamma 3, and if you know about Google's latest model, DeepSeek R1, why to use Unsloth, and this is pip install Unsloth. It is that easy. You just need to pip install. The scripts are quite good. Here you can see all the guides are present on how to use Unsloth. Our models installation fine tuning guides are present. You can go through everything. Text to speech fine tuning is also there, that I would be covering soon in the upcoming videos. Gamma 3 fine tuning is there. Which version you want to fine tune, everything is present here. And the codes are quite easy, I would say. Here you can see that using a free Colab notebook. If you click here, you can see that press runtime and press run all on a free Tesla T4. That means you can fine tune Gamma 3 on a free GPU on Google Colab. That's the best part. I think what are you waiting for now? The codes are also quite small. If you see, it's not very complicated. If you jump onto, you will see that the codes are very easy to implement also. So I hope you try out Unsloth for fine tuning your custom LLM and let me know how you feel about it. Thank you so much.